Phenomenology. Phenomenology.
Phenomenology. Okay, got it. Hi guys, welcome to my YouTube channel. Um, so I was listening to this podcast by FizzBuzz. If you guys don't know them, you should check that. You should check him out. He's been making videos for a while, and this is all the way from 2017, and he still like made a upload last week. So like it's pretty active if you're into philosophy. I just got into it recently, so I won't say I know a lot about philosophy, but I'm very interested in it. Anytime I find a concept I am trying to understand in philosophy, um, I there is most likely a podcast from him about it. So I just come and search, and that's why I'm listening to a podcast from 2017. And in this one, see, I'm not done. But the idea is it's talking about phenomenology. It's talking about phenomenology, and um, this guy called Husserl. So Husserl is a philosopher and a mathematician, right? Who worked on it, and I promise we're gonna get to FizzBuzz in a second. But the core idea of phenomenology is to not reject abstractions. It's not to reject thinking or assumptions of the world, but it's to set it aside for a minute, just like set it aside for a minute and try to fundamentally understand the experience. Um, I'll explain what that means and the context around that shortly. But I think a good way to get to that point is to talk about like AI and where we are today, where like you know information is readily available to us, right? Like even just like in my work, I'm a software engineer, so like writing code or like building something, it's very easy to just like prompt AI and AI gives you the answer. I don't have any like moral or like I don't have a stand on this yet on AI coding because I use AI coding a lot. And it definitely has like its positives and negatives, but like just in this world where information is just like very available to us, and then we're listening to all these podcasts, we're watching all these videos, and we're just like AI is giving us lots of like content, recycled content. Like I think it's more important than ever before to set these things aside a bit and examine things from first principles, right? Like it's very easy to say, I used to say back in high school, I understood quantum physics because I read a book. I did not finish that book, in fact. Or I watched a sci-fi series. I watched a couple of YouTube videos about quantum physics and superposition and quantum entanglement, right? And the double slit experiment. And I thought like I knew shit about quantum physics. But turns out, fundamentally, I still did not understand. And this was like in high school, right? Which wasn't that long ago, to be honest. But like, I thought I understood quantum physics, and I really just didn't, right? And I think it's our human instinct to just not want to be dumb, and I think like more than ever before, we need to accept like being dumb, not knowing something, like set that aside and just like fundamentally reevaluate like the experiences and like ask first principle questions. And this is how I've been thinking for a while, and fortunately for me, I found this guy Franklin on YouTube. He's been my favorite channel. I've watched almost all his videos, as you can see. And he talks a lot about these things, and if thinking is out of fashion, and how a lot of what we say we know today is just like recycled content from other YouTubers or podcasters, or like you just like a snippet online, right? You get, or ChatGPT, right? And we don't really know these things fundamentally, right? We don't think like from the first principle. We just don't even think at all. And I have noticed this a lot, right? Me myself, where okay, why am I implementing? Why am I using this language, or why am I working on this right now? Why is this the path to take? Of course, as an engineer, I can say, okay, these are the pros and cons of this. But like fundamentally, if we strip it down, do I really understand like how the interpreter is gonna, or how the compiler is gonna handle that, or how this actually scales? Like okay, we can say we understand scaling, but like strip it down to the basics. Do we really understand what we are trying to do here? Alright, so I said to myself, like, what's the best way to start, embracing this thinking of first principle like reasoning, stripping away or temporarily suspending assumptions, and just like approaching things from the experience, like working my way up to like I want to construct my thoughts, right? I want to be very constructive about like things I see, I know, right? I need to be able to strip it down, and that led me to FizzBuzz, right? That led me to FizzBuzz, and FizzBuzz is it's a classic, um, it's a very classic, you know, programming concept. Um, and the thing with FizzBuzz is you're given a simple test where for multiples of, I mean, say given to multiples of two numbers, let's say 3 and 5, right? For multiples of 3, you have to print fizz, and multiple of 5 prints buzz. But if there is a number that is divisible by both 3 and 5, you should print FizzBuzz. That's like programming 101. Anybody who has learned like conditionals, loops, right? Just the basics of computer science and just writing code. You know, you can actually just ChatGPT this shit, right? Like, you know, let's see a code snippet of ChatGPT of FizzBuzz real quick. All of this works. Let's just do this here. Open link in new tab. Yeah, I don't have a LinkedIn account connected. Yeah, okay, I do have a LinkedIn account connected. But yeah, this is the classic FizzBuzz, right? So there's a loop from 1 to 100, right? And for every number in 1 to 100, right, you just check. We're going to talk about this shortly. If the number is divisible by 3, right? So divisible means, you know, you can divide it and have 0 remainder, right? So we use this. And then divisible by 5, we say buzz. And if it's divisible by both 3 and 5, we say FizzBuzz. Now, a lot of people just copy this snippet, right? I know a lot of junior developers, just developers that would just copy this and just expect that, okay, yeah, this is how it works, so like we should just accept it. But people don't really understand, like, okay, they can say 15 is divisible by you can divide 15 by both 3 and 5, so it works and it passes the interviewer's question that like 15 is divisible by 3 and 5. But people don't fundamentally ask why 15, why not 13, why not 60? I mean, those numbers work. Why are we using 15, right? And we can say intuitively it's because, yeah, 15 is, you know, the closest thing we can think about as divisible by both 3 and 5. But then that's a level of abstraction, right? That we've just accepted that level of abstraction that, yeah, because this is divisible by 3 and 5, we've just accepted it and, like, you know, yeah, let's just go our way. Like, there's lots like bigger problems. There's AI, there's quantum physics in the world we need to figure out, and we don't give a shit about. Am I still recording? Okay, yeah. And we don't need to give about. We don't need to care about that question itself. And that's not something I'm trying to do, right? So I said to myself, I'm going to be the best person at FizzBuzz ever. And that makes no sense because anybody can do FizzBuzz. But like what I meant by that is I need to fundamentally strip down FizzBuzz to the first principles, and I need to be able to reconstruct it in my head, like from down to the top, right? So let's set some common grounds here. We know the conditions. If it's divisible by 3, it says false. If it's divisible by 5, we say buzz, right? But that condition where we say if it's divisible by both 3 and 5, you know, by the way, we can, if we want to make this lengthy, we can say if it's divisible by both 3 and 5, right? Instead of thinking about 15, we can say this LCMs, right? Or I actually marked yeah, least common multiples, right? I probably made that mistake. Yeah, it's least or lowest, right? So let's just say lowest common multiple, yeah, right? And then 15 in this case is the least or lowest common multiple of between 3 and 5. What are multiples of 3? What are multiples of 5? So multiples of 3 includes 3 itself, 6, 9. Multiples of 5 include 5, you know, 10, 15. So like, you know, 5 is a multiple of 5, 10 is a multiple of 5, and all of that. So to find the lowest or least common multiple between 3 and 5, like at what point do these two numbers and their multiples intersect? What's the least common multiple between them, right? So I have a Notion document I wrote for myself, totally not AI generated, I promise you. Like, this is what I'm trying to do, right? So you have multiples of 2, multiples of 4, the least common multiple between 2 and 4 is 4, because 4 is a multiple of 2, right? And 2 has 4 as its multiple, and 4 is a multiple of 4 itself. So the least common multiple is 4, and we can do the same for 2 and 3, right? So in this case, like 3 is not a multiple of 2, so the next multiple of 3 as a multiple of 2 is 6, right? So again, to understand the abstraction in this FizzBuzz technique, I had to go back to understand LCMs, and now, like, you know, the first I'm just like understanding how that, like, that is what LCMs mean, like fundamentally. Like when I growing up in primary school, we're taught LCMs, like, even in a very like abstract, we're just given like you have to draw a table to find the LCMs, but we really did not internalize the math, and I was very bad at math in school because I couldn't internalize it, right? And that's what I'm trying to do right now, and I feel like it's going to even be like more difficult for the next generation of people growing up, and like me, if I'm growing up again, right? We just like, so we build so, like, humans are good at building so many abstractions. Nobody wants to do the boring work of like really understanding these things or going back to first principles, and that's what I'm trying to do this new year, and just like all of my life. Like, I know I have, like, I'm working multiple things, like I'm on multiple projects, and I'm tracking a lot, and I'll still be doing those things, but every week, every time, I need to pick a concept. I'm able to abstract to the first principle, and I need to think. I need to be able to think again. Like, I feel like that's so out of fashion, thinking. I just need to be able to think and reason my way up things again. Sorry for that cycle, but yeah. So intuitively, this is how it works, right? You take two numbers, get each of their multiples, and like, okay, what is the first point they intersect? And my brain, so I asked myself this question. No ChatGPT, nothing, just my head, myself. I was like, okay, so how do you find the LCM intuitively, just with what you know, with everything and your experience, your 20 years in life? Like, how would you find the LCM of any two numbers? And then the first thing that came to my head was this technique of, so you have a number 2 and 4, right? You start from the big number 4, and because the big number has the shortest number, it has the shortest distance to the multiple of between the bigger number and the small number. So given 2 and 4, of course 4 is going to reach the fastest common multiple, which is itself in this case, before it reaches 2, right? Or 3 and 6, or 2 and 6 rather. 6 is going to reach 6, of course, before 2 reaches 6. So why don't you just start from the number that has the shortest distance with, like, to the multiple, which is always going to be the biggest number, and then work your way that way. So between 2 and 3, or 10 and 50, for instance. Now 50, 10 is always going to get to 50, right? We know that. And then 50 is a multiple of itself, right? So the lowest common multiple is going to be 50 in that case. And that's, I felt like I was Einstein when I came up with that, because I have never thought about a problem in a long while that way. And this, like, you guys might be like, LCMs are like the most simplest like things ever, but like, trust me, just me being able to sit down and reason by myself, right? That, like, okay, that is the way you can do LCMs. Just start from the bigger number and assume, right? Not even assume, right? Start from the bigger number and then work your way, and I find readings from there, right, that also intercepts with the smaller number, right? But because I thought about this, of course, I reached the point of where like, you know, that's not scalable. That brute forcing approach is not scalable, right? And you see how now I've gotten to a point where I can justify the need of an abstraction to find LCMs, right? Now I can ask myself, is there a way where, like, you know, like, I've reached a point of scale where, sorry, I'm like all over the place. This video is for me, and then just like very few people who can relate to what I'm saying, and now I'm rambling. I'm not going to edit this video, by the way. I am not going to edit this video. I just want to record it and post immediately. But like, I hit a problem where I asked myself, you know, given 89 and 98, these numbers are like very big for me to grasp, right? And my brute forcing knowledge, or my brute forcing approach to finding the bigger number, in this case 98, and finding multiples of it that would intersect with 89 would not work, because that's just like a very big thing for my tiny head to comprehend. And it's not a logical problem, it's a brute forcing issue, right? and that's like led me to a point. Like now, I found I constructed my way through abstraction. Right now, I understand why they are abstractions. I understand how we can use primes to find LCMs. And I've not gone down that rabbit hole like real quick, but like now, I did not just accept the abstraction that this is the fastest way to find LCM. You can just ask Gemini or any AI tool you use that, okay, find like the LCM, right? Or just give you a technique to the fastest technique to find it. I did not start from that. You see, I started this exercise by like taking away my abstraction, taking away my assumptions on FizzBuzz, and now like very straightforward. Just need to find a number that is divisible by those two numbers. And I didn't even know it uses LCM. I didn't even think of that. I didn't even associate that cognitively with LCMs. I just knew it was like you're cramming the concepts down, like internalizing it. And this might seem so stupid and very lame that I'm doing this. I don't really give a fuck, but still, it's like this is how I want to approach problems, where you strip them to the first principles, and you really ask the basic questions, right? Like genuinely, like, and then that even exposes the bigger dilemma, right? That Franklin was also talking about, and I relate to, like, okay, what level of abstraction do you get to? Okay, so to understand FizzBuzz, you need to understand LCMs. To understand LCMs, you need to understand multiples. To understand multiples, you need to understand, I don't know, very basic maths. And then you keep just going down until you get to like, quantum physics or something like that. I don't think so. I was speaking to my mentor because it's the holidays, so I went back to his house after a couple of years, and I was speaking about this problem with him and FizzBuzz to him, and he said like, where you should stop is, what makes more sense, like intuitively, like, that's the lowest level of abstraction. Like he spent so many years reading so many books, he told me, right? And then one day he just woke up and said like, I've been consuming a lot of stupid knowledge, right? Like things that I don't fucking need. Alright, and I don't want to get to that point, right? So I need to also find a point of just like going down this rabbit hole, because this is going to be bigger than FizzBuzz. By the way, I'm working on much more complex things. I have products live right now that are genuinely so fucking complex, and I'm managing this and I'm worrying about FizzBuzz during the holidays. Like, it's make that make sense. But still, like, at what level of abstraction do I stop? At what level of abstraction makes sense to me? And this is going to be a part 2 of this video. I might continue talking about FizzBuzz, and other concepts I end up exploring to just understand FizzBuzz. Like, I'm reading. I started from philosophy, and now I'm in math. I might be going through like history. I love philosophy, by the way. I just love philosophy. And generally, I think this is what I want to do. Like, I'm going to be making a video every week going forward, talking about how I am analyzing some of these concepts and how I am navigating the world through first principle thinking. And I just hope you guys like this type of content. Sorry it's unedited, unfiltered. It feels like I feel like you guys are used to streaming and switching and just like using Twitch. So like my audience should understand unfiltered content, and hopefully this is like 10 minutes. I don't know how long this has been of your time that you can spend after this thinking about like concepts you think you understand. Really, it's not about what you don't know, it's about what you know that you don't know enough, or it's like completely wrong, and you need to like go back to first principles. Bro, you can say you understand React, or you understand like back-end development, but like really, if you strip it to the fundamentals, do you really understand those things, or like you're just like repeating what you heard from a YouTube video, and maybe you don't even need to understand those things, and I'm just thinking too much about it. I don't know, guys. Like, this is where I am. It's December, the last day of the year, 31st, and I'm making a video about FizzBuzz and philosophy and LCMs. Catch you next week. Let me know if you guys have any ideas on how like I can better do these videos, or just like your thoughts on like how you guys have internalized math concepts before. If you guys passed maths in school, I love physics too. So like understanding like internalizing these abstract concepts are just like very like amazing to me. Yeah, catch you guys in the next one.